Okay, Wildcats. Today we're going to Wednesday, January 30th, solving square root equations on page 48. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. Solving square root equations on page 48. Solving square root equation steps. Step 1, isolate the square root. Step 2, raise both sides of the equation to the power of 2. Step 3, simplify and solve. Step 4, check for extraneous solutions. All right, if you would, update your notes. Now your notes are updated. Let's take a look at our examples. All right, solve each equation. Remember to check for extraneous solutions. Okay? All right. Now, example 1. We're going to isolate the absolute value, which it already is isolated. Now we're going to square both sides. Now, when you square this, it becomes power of 1, so you have 2x equals 6 squared, which is 36. Divided by 2, x equals 18. Okay, now we need to check. Now to check, you substitute the number into the equation and see if it's correct. So that's the square root of 2 times 18 equals 6. All right. Well, 2 times 18 is 36, so the square root of 36 equal to 6. Well, the square root of 36 is 6, so 6 equals 6. So it checks. All right, let's take a look at example 2. All right, so first we need to isolate the absolute value. So we're going to add 3 to both sides. So we have 2x to the 1/2 power equals 8. Now the square root is isolated, so now we need to square both sides. One half times 2 is 1. 2x to the 1 power is 2x. 8 squared is 64. Divided by 2, x equals 32. All right, now we need to check. Check, we substitute this number back into the equation. So that's 2 times 32 to the 1/2 power minus 3 equals 5. So here, 2 times 32 is 64, so that's 64 to the 1/2 power minus 3 equals 5. 64 to the 1/2 power is 8. 8 minus 3 is 5. So 5 equals 5. So it checks. All right, so finish up example 1 and 2. All right, now let's take a look at example 3. Now the first step is we need to isolate the absolute value. So we're going to multiply, if we put here a 1, we can cross multiply. So square root of x plus 5 times 1 is the square root of x plus 5. And 3 times 4 is 12. All right, the square root's isolated. Now we need to square both sides. This becomes power of 1. You get x plus 5 equals 12 squared is 144. Subtract 5 from both sides. X equals 139. So now we need to check. So we have the square root of 139 plus 5 divided by 3 equals 4. Well, 139 plus 5 is 144. The square root of 144 is 12. So this is 12 divided by 3 equals 4. So 4 equals 4, and this checks. All right, example 4. So first thing we're going to do is isolate the square root, which it is. So now we're going to square both sides. So this becomes x minus 4 times x minus 4 equals x minus 2. So we need to FOIL this first. So x times x is x squared minus 4x minus 4x plus 16 equals x minus 2. Now we need to subtract 1x from both sides and add 2 to both sides. So then that's x squared minus 8 minus 9x, and then 16 plus 2 is plus 18 equals 0. Now we need to factor this. We know x and x makes x squared. We need to find all the combinations to make 18 combined to be negative 9. So we know that negative 1 times negative 18 is positive 18, and negative 1 minus 18 is negative 19. That didn't work. Negative 2 times negative 9, oh, I'm sorry. So, yep, no, that's right. Is positive 18. And then negative 2 minus 9 is negative 11. So negative 3 times negative 6 is positive 18. Negative 3 minus 6 is negative 9. There's our combination, negative 3 and negative 6. So x minus 3, x minus 6. This is quite a long problem. I'm actually going to steal some space from this problem. Okay, so then you have x minus 3 equal to 0, x minus 6 equal to 0, so x equals 3 and x equals 6. So now we need to check both numbers. So let's do 3 first. So 3 minus 4 equals the square root of 3 minus 2. Well, 3 minus 4 is negative 1. 3 minus 2 is the square root of 1, which is 1. It's not true. So we would say that x equals 3 is an extraneous solution. Okay, now let's check 6. So 6 minus 4 equals the square root of 6 minus 2. Well, 6 minus 4 is 2. 6 minus 2 is 4. Square root of 4 is 2. This checks. So that's an extraneous solution, and this is a solution. Okay? All right, let's take a look at example 5. All right? Now, in example 2, we worked with the 1/2, but you can write 16 to the 1/2 as the same thing as the square root of 16x. So that's what we're going to do. So in essence, I'm going to ignore this and I'm going to work with this. Now, the square root's isolated, so we're going to square both sides. So then that's x minus 12 times x minus 12 equals 16x. So x times x is x squared minus 12x minus 12x plus 144 equals 16x. We need to subtract 16x from both sides. So you get x squared minus negative 24 and negative 16 is negative 40. X plus 144 equal to 0. So now we need to factor. We know x and x make x squared. Now we need to find all the combinations that make 144 and combine to be negative 40. So we know that negative 1 times negative 144 is positive 144. Negative 1 minus 144 is negative 145. That didn't work. Negative 2 times, and now at this point the number's kind of big, so I'm going to use a calculator to find all my combinations. So, new document, no, it's a little bright, so let me unbrighten this a little bit. Okay, so I'm going to add graph. I'm going to do 144 divided by x, enter, control T. There was one combination. Now my next one is 272. So 2 times negative 72 equals positive 144. Negative 2 minus 72 is negative 74. That didn't work. Now we look at the next combination, 3 and 48. So negative 3 times negative 48 is 144. Negative 3 minus 48 is negative 51. We're getting closer to 40, but that didn't work. Now let's try 4 and 36. So negative 4 times negative 36 is 144. Negative 4 minus 36 is negative 40. That combination works. So negative 4 and negative 36. So x minus 4, x minus 36. And so you can honestly go from here to saying x equals 4 and x equals 36. I don't know why it keeps going blurry. Maybe the camera, the math is overwhelming the camera. That's what it is. All right, so x equals 4 and x equals 36. So now we need to check. Now you can write check, but we don't have to. Because we're at limited space, we're not going to. So we'll do 4 minus 12 equals the square root of 16 times 4. 4 minus 12 is negative 8. 16 times 4 is, I believe, 64. So square root of 64 is 8. This doesn't check, so we would say x equals 4 is extraneous. Okay, so now let's check x equals 36. So 36 minus 12 equals the square root of 16 times 36. Well, 36 minus 12 is 24. And then 16 times 36 is 576. The square root of 576 is 24. So this checks. So this answer is a solution. This is extraneous. All right, example 6. All right, first thing we need to do is isolate the square root. So we're going to subtract 8 from both sides. We get the square root of x equals -6. Then we square both sides. That becomes x. -6 squared is 36. So now we check. So in space, you really want to write check the x equals number so you know what you're checking, and then substitute in. So we have the square root of 36 plus 8 equals 2. Well, square root of 36 is 6 plus 8 is 14. 14 does not equal 2, so we would say that x equals 36 is an extraneous solution. All right, let's take a look at example 7. All right, so here we isolate the square root. There's nothing we can isolate. It's as isolated as it can be. So we're going to square both sides. Well, that becomes power of 1. That's x plus 4 equals, this becomes 5 square roots of x minus 20 times 5 square roots of x minus 20. So that's x plus 4. 5 times 5 is 20. Square root of x minus 20 times square root of x minus 20 is just x minus 20. And I made a slight mistake. 5 times 5 is 20. It's 25. All right, so now we have 1x plus 4 equals 25 times x is 25x. 25 times negative 20 is negative 500. We're going to subtract 1x from both sides and add 500 to the other. So then we get 504 equals 24x. Divide 24 by both sides. So 21 equals x. All right, now we need to check. So x equals 21. Now we're going to substitute that in. So we have the square root of 21 plus 4 equals 5 times the square root of 24 minus 20. So that 21 plus 4 is 25. Square root of 25 is 5. 24 minus and hold on, slight mistake. Put a 24 there. That should be 21. 21 minus 20 is 1. So 5 times 1 is 1. So it checks. I apologize for the mistakes on X7, but they are fixed. That's 25, that's 21, so the math does fall correct. All right, example 8. So we square both sides. So then I don't like with the 4 plus x. I'm going to rewrite it as x plus 4. So that's x plus 4 times x plus 4 times or equals x plus 4. So now we FOIL, that's x squared. And I'm going to put a 1 in front of there and a 1 in front of here. So you're going to subtract an x from both sides. So you have 5. And actually, before you do that, there's nothing we do with the next word. We have 8x subtract 1x, that's plus 7x. And then we have 16 subtract 4, that's plus 12 equals 0. All right, now we need to factor. We know x and x makes x squared. Now we need to find all the combinations to make 12 and combine to be 7. So 1 times 12 is 12. 1 plus 12 is 13. That didn't work. 2 times 6 is 12. 2 plus 6 is 8. That didn't work. 3 times 4 is 12. 3 plus 4 is 7. That works. So x plus 3, x plus 4. So you have x plus 3 equal to 0, x plus 4 equal to 0. So x equals negative 3, x equals negative 4. So now we need to check. So we substitute negative 3 in, so that's 4 minus 3 equals the square root of negative 3 plus 4. That's 1 equals 1. That checks. Now we need to check x equals negative 4. So then that's 4 minus 4 equals the square root of negative 4 plus 4. So 0 equals 0. So both answers actually check. They are both correct. All right. So there you go. If you would finish up your examples, start working on your assignment, and have a wonderful Wildcat